Hi. I've had I had one comment that it would be better to be working on a whiteboard, so that's why I've moved to this room. And I had a couple of questions from one student about assignment number 2. And so I'm going to give you a few little mini lessons that I think will help with that. The first mini lesson is around question 9 on page 253, in which you're asked to figure out what would happen if you draw a ticket at random from 2 boxes. So obviously I'm not going to work on that particular problem, but what I'm going to do, I think, is to do something that I think should be fairly similar and be of a help to you in figuring out, and sorry, I'm just moving this around to try and get it to a good spot here, be a help to you in terms of getting a handle on what kind of solution you'd be giving to this. So what I'm going to do is I'm going to talk about if you're rolling dice. Rolling dice is a lot like drawing you're rolling a single six-sided die. So, one that looks like this, more or less. I may not have the right number of dots on the right spaces. I think there's actually something to how that all works. But anyway, if you're rolling a single six-sided die, it's like drawing on a box from 1 to 6. And so what we're going to do is we're going to actually look at drawing from 2 dice, and we'll say one of them is going to be red, and one of them is going to be blue. So this will be the red die. Die, of course, is the singular for dice. And then this is going to be the blue die here. Okay? And so what we'll do now is we'll talk about what can happen. And so what can happen for the red die is that the red die you can get a 1, a 2, a 3, a 4, a 5, and a 6. And all of those are equally likely. Equally likely outcomes of throwing the red die. And then for the blue die, same story. There's 6 equally likely outcomes. You get 1, 2, 3, 4, 5, and 6. And so what's going to happen here is I'm going to make a little table. A 6 by 6 table that looks like this. All that dead air time as I draw this table. If I'm learning to do YouTube videos, the lesson is get that done beforehand. Okay, so now, what is this cell here? This table has 6 times 6, or 36 cells. So 6 times 6 is 36. So what is in this cell here? Well, this is the cell that's really the outcome that you roll a 1 on the red and a 1 on the blue. And this would be the cell that's the outcome that you roll a 3 on the red and a 2 on the blue, and so on. Okay, so that's what that means. And what I'm going to assert to you is that all of these cells, all of these outcomes, all 36 outcomes are equally likely. And that's so important that I'm going to write it down. So all 36 outcomes are equally likely. Okay? And so that means each one has a chance of 1 in 36 of happening. Each of those cells. All right? What's really important, that's the basis for everything we're going to be doing. And of course, this assumes that the dice are fair and not loaded. Okay, but that's an assumption. And also that they're independent. That the roll of outcome of one die doesn't somehow affect the outcome on the other die. Which is probably true, more or less true in the real world. Okay? So now we're going to ask ourselves a question. And I want to make a question that's somewhat similar, but not too similar to the questions in number 9. So the questions in number 9 were, find the chance that the number drawn from A is larger than the one from B. Find the chance that the number drawn from A equals the one from number B, and find the chance that the number drawn from A is smaller than the one from B. Okay, so we'll do something that's like that. So let's see, what would be, okay, here's one we could do. Find the chance that the sum of the red die and the blue die is greater than 5. So in other words, it's 6 or more, okay? Because it has to be a whole number. So what I would do is I would basically go through every 36 cells and ask myself, well, what's the sum going to be? Is it going to be greater than 5 or not? Now, actually, what I'd probably do is I'd probably write the sum in every cell and just then circle the ones that are greater than 5. But that would be a little different from what would help you with number 9, so I'm going to do it slightly differently from how I'd probably do it. I'm just going to go through each cell and say, okay, what's their sum here? Is it greater than 5? No. So I'm not interested in that cell. The sum is 2. The sum is 2 here. 1 plus 1 is 2, so I'm not interested in that cell. 2 plus 1 is 3, not interested in that. 3 plus 1 is 4, not interested in that. 4 plus 1 is 5. 5 is not greater than 5, so I'm still not interested in that. But 5 plus 1 is 6, and I'm interested in that. And 6 plus 1 is 7, and I'm interested in that. We could go along like that. 2 plus 1 plus 2, no. 2 plus 2, no. 2 plus 3, no. 2 plus 4, yes, yes, and yes. And so on, and you'll see a pattern that forms here that we're interested in all these guys. Now that's a check, not a tick. Check, not an X. Check, check, check. Check, 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 check. So now we've got how many? Let's see, we've got 2 plus 3 is 5, 9 plus 5 is 14, plus 6 is 20, 26 out of 36. So there's a 26 out of 36, or 13 out of 18 if you reduce the fraction chance of having the sum be greater than 5. Okay? Now, I'll do another example, another question with the same example. So, let's see. This one maybe will be a little bigger, a little more like the one in that one. Well, actually, why don't I just do one that's really similar. So let's say, but I'm going to do one that's actually a little more complicated than the one you're going to find. So let's say, let's find the probability that the roll on the red die is more than twice the roll on the blue die. I'll write that down. So you're supposed to find the chance that the red die, the number on the red die, is more than twice the number on the blue die. Okay? So let's see. So we're just, again, going to go through and say for which one is those. So the red die is 1, that's not more than twice in 1, so we're not interested in that one. The red die is 2, that's not more than twice in 1. It is twice 1, but it's not more than twice 1, so that's no good. But 3 is more than twice 1, so that's a good one, so it's 4, so it's 5. Okay, they're all more than twice 1. Now for 2, 1 is not more than twice 1, 2 is not more than twice 1, 3 is not more than twice 1, 4 is not more than twice 1, but 5 and 6 are. And now for 3, well, twice 3 is 6. Nothing's going to be more than 6 on the red die. So we're just going to, and I think you can see that the rest will all be no-goes. So we've only got 1, 2, 3, 4, 5, 6 out of 36. So the chance of 6 out of 36, or 1 out of 6, that the value on the red die is more than twice the value on the blue die. Okay? So that's pretty much how this kind of question goes. So what the primary thing you're doing is you're assuming that all the 36 outcomes here are equally likely. Now, in case you can't exactly see how that applies to the problem in the number 9, I would throw out the extra comment that you're kind of looking at a 3-sided die and a 4-sided die. Okay? So good luck with that problem. Thanks to the student who asked about it, and I think a lot of people will probably be happy that a student did ask about that. So that's, again, just some help on basically how to set up probability questions like the one on page 253. All right, that's all for this one. I'm going to give a couple more answers to questions, but that's all.